In this segment, I want to show you a little bit of the list source code to clarify a few of the points I made about how structure pointers are used in particular. So I'm going to share list.c, and I'm going to show you list init, list destroy, and list to string. So this is list.c, and in list init, what I just want to point out is the strategy is that when a person uses a list, a client uses a list, they pass in these three function pointers like I showed you in test list. And this is how to destroy the particular type of object they're storing in that particular invocation of the list. This is how to tell if any of those two match, which I'm not using for the list, but I could use it for other things. And this is how to represent textually an instance of whatever you're using, okay? So when you pass these three things in, all this, what I call constructor method does, is just store those three function pointers in the fields of the structure list.destroy, list.toString, and list.match. So once you've called list init, this opaque list handle that the user is using to manipulate the list has these function pointers stored. And then when you call another list function, for example, list destroy, you always have to pass in list as the first argument. So it has those functions available to call. And it's good that it does because, for example, if you want to do list destroy, you can loop over the list. So this just says until you have looped over the entire list, remove the next element, starting, say, with the head each time. So this always says remove the head of the list. And you pass in a pointer to the data pointer associated with the particular object type that you're storing. You pass a pointer to it because it returns, that's essentially passing a pointer by reference. So this function essentially returns a pointer. It returns a void pointer that is modified within list rem next. And so now you have a handle to the data that was in that element of the list. And then you call list.destroy. Well, destroy is the function that you passed in when you initialize the list. It says how to free the memory for one of those elements. And so it knows how to destroy the data, okay? So it was critical for being able to free the list for you to tell the list implementation how to free an element. And similarly, I won't show you all my source code, but there are no secrets with some of this stuff. If you want to print the list, I can loop over each element. So I just say, well, node is not null. I print, but I can't say print the element type of the data of the list because it's an aggregate type. So I say print list.toString node.data, right? And this converts the node data to a string representation based off of the function that I passed in. So anytime you're using the list, you have to give it a little bit of information to say how to work with your stuff, okay? And so then I can print it. And the other functions, I'll follow the strategy that we used in class. Again, there are a lot of different ways to divide up the work. There are a lot of different levels of abstractions at which you can present it. And there are multiple techniques, at least, for doing some form of abstraction. And there isn't really a right or wrong answer. So I want you to explore and do something. You could follow this approach, that's fine, but there's still a lot of detail that I didn't show you that I think is a very good experience to try to design. Okay, so I'll show you that much, and then on Sunday evening, I'll go over your submissions, and then we will discuss them during the synchronous session on Monday.